this lesson, we're going to be talking about different types of expressions. An expression is any mathematical operation without an equal sign. And we're going to learn about two different types of expressions. One is called a numerical expression. If you look at the word numerical, you can kind of see the word number. And the reason is it's an expression containing only constants, powers, and operations. In a moment, we're going to talk about what constants are. I already know that you know that what powers and operations are, but let me give you some examples of a numerical expression. 2 plus 4 is a numerical expression because it's just numbers and operations. 2 squared plus 4 is also a numerical expression. Basically, if it just has numbers and there are no variables or letters attached, you have a numerical expression. So let's talk about this algebraic expression. It's an expression containing constants, powers, variables, coefficients, and operations. For example, 2x plus 4. This is an algebraic expression mainly because if you look at the x here, that's a letter. If you have a letter, that means that it's an algebraic expression. All right, let's talk about some of these vocabulary terms. So constant, what is a constant? A constant is just a number all by itself. So in the example that you see here, negative 3x plus 12, positive 12 is the constant in the expression. It's just the number standing alone. Then the word coefficient. It's a number multiplied by a variable. So if you look at our expression, the variable x is being multiplied by negative 3, which makes it a coefficient. The coefficient is always in front of the variable. Sometimes you have unique situations where you might have something that looks like this, x plus 4. And we want to know what is the coefficient of the x. Well, when there's nothing in front of the x, that means that there's actually an invisible 1 in front. So in that case, the coefficient of x would be 1. We don't really write it there. It's not common to see it written there. So it's kind of one of those things you just have to remember. All right, what is a variable? We already talked about this. This is a letter, any type of letter or symbol representing one or more numbers. In our case, of course, our example is x. A term, it's a number, variable, product, or quotient, not a sum or difference. Let me show you what I mean. Up here in our example, you can see that we have negative 3x and we have positive 12. These two pieces are called terms. We're going to see that a really good example of that in the next problem. Okay, let's go ahead and look at this. It says use the expression to answer the questions. Here's my expression. It's a pretty big expression. And before I begin and answer my questions, what I want to do is I want to draw little lines. I want to draw a line right after each variable. Okay, that kind of separates things and you'll see why. My question is, what is the coefficient of x? The coefficient is the number that stands in front of the x. In our case, it's negative 3. What is the coefficient of y? It's the number that stands in front of the y, which is going to be positive 6. What's the coefficient of z? Well, it looks like a 3, but it's actually going to be a negative 3. You can see that my line between my y and my minus sign breaks everything up to kind of show you that negative 3 is my coefficient. What are the variables? Well, my variables are all my letters, so x, comma, y, comma, z. What's the constant in the expression? The constant is the number that stands alone. So again, notice that line, and notice my constant. Minus 12, or negative 12 is our constant. How many terms are in the expression? Well, remember a term is something like a negative 3x. So that's one term, then I have another term, and another term, and another term. So in this case, I have 1, 2, 3, 4 terms. Okay, let's try another example that's a little bit more challenging. All right, here's my expression. It says use the expression to answer the questions. What are the variables in the expression? Well, before I figure that out, I do want to go ahead and draw my lines. So I'm going to go ahead and draw lines after those variables before I answer any of my questions. Okay, my variables. That looks like it's going to be m, y, g, and f. What's the constant in the expression? The constant is the number that stands alone, and it is at the end. It's positive 7. How many terms are in the expression? Well, I have 1 term, 2 term, 3, 4, 5 terms in this one. What is the coefficient of the m? Number that stands in front of the m is 5. What's the coefficient of the y? All right, well, this is a tricky one. Going back to that comment that we made earlier, if I had an x, I would have an invisible 1 in front of it. So here I have a y, I have an invisible 1 in front, but actually it has a negative 1. So my coefficient in front of the y is negative 1. And what's the coefficient of the g? Well, that's going to be positive 8. Okay, now that we've talked a little bit about expressions, now we're going to do something called evaluating. Basically, the word evaluate, that word, all it means is to solve. Equations, when you have an equation, you solve, but when you have an expression, you evaluate. So let's talk about this word replacement value. What it is a number substituted in for a variable. So what we're going to be doing here is we're going to be taking numbers and substituting them in for variables. So let's look at the first problem. If x equals 3 and y equals negative 1, evaluate negative 6 times x times y plus 3. Okay, this is how we set these types of problems up. We always start with the same step each time. I'm going to rewrite everything and I'm going to put parentheses around my variables. This step, although it doesn't really take you very long, it is one of the most important steps of this process. Okay, now I'm going to substitute my replacement values, which are x equals 3 and y equals negative 1, into my expression. So I'm going to say negative 6, and instead of saying x, I'm going to replace the x with a 3. My y, instead of writing a y, I'm going to replace it with a negative 1. And then I'm going to bring down my plus 3. In Unit 1, we talked about integers and all the operations with integers. So here, we're going to be doing some multiplication. So I'm going to do this in a couple steps here. I'm first going to start by taking negative 6 times 3, which is negative 18. And I'm going to go ahead and bring down everything that I have not used yet. And I'm going to continue my order of operations. Negative 18 times negative 1 is going to be 18. Bring down my positive 3. And then my last step is 18 plus 3, which was going to give me 21. So this expression evaluates to 21 given those two replacement values. All right, let's do another one. Now I'm given x is equal to negative 2 and y is equal to 5. And I want to evaluate negative 5x minus 3y. I'm going to start with my first step, negative 5. I'm going to put my x in parentheses. Again, that's very, very important. Do that first. Now, my second step is replacing them. Negative 5 times negative 2 in parentheses minus 3 times 5. Okay, let's go ahead and use order of operations. I have negative 5 times negative 2 is going to give me positive 10, and I'm going to carry everything down just the way that it is. Now I'm going to go ahead and do 3 times 5, that's 15. So 10 minus 15. And then I'm going to finish it off, and my last number is going to be negative 5. So this expression evaluates to negative 5. Okay, let's try some more challenging problems. These ones have squares in them, so we know how to use squares from Unit 2. So let's go ahead and try this. If x equals 3 and y equals negative 1, evaluate 2x squared plus 3y squared. All right, first step, as always, put your variable in parentheses. Notice how my power is staying outside of my parentheses. Only the variable is going to go inside the parentheses. Okay, let's go ahead and plug the numbers in now that we have our parentheses. Okay. All right, let's go ahead and use order of operations. It looks like I have some exponents to work with. I have 3 squared. 3 squared is 3 times 3, which is 9. So now I have 2 times 9 plus 3 times negative 1 squared. And I still have more exponents, so let's go ahead and do negative 1 squared. Negative 1 squared is negative 1 times negative 1, which is 1. So I'm going to say, I'm going to replace that with a regular positive 1. And now I have 2 times 9 and 3 times 1, so I have 18 plus 3, which gives me another answer of 21. And the last one, this one's a little challenging, and this one's really going to show you why we do this first step that we do. So let's go ahead and do the first step first. All right, negative. I'm going to put my variable in parentheses. Notice how the negative is not in the parentheses with it. Okay, now I'm going to go ahead and put the numbers in. Negative, negative 2. Be very careful here. Notice how the negatives kind of, they double up. I have one outside and one inside. Okay, order of operations says exponents first, so let's go ahead and take care of negative 5 squared. Notice negative 5 is in parentheses, so it's going to be negative 5 times negative 5, because negative 5 is my base. So I have negative negative 2 plus 25 plus 3 times negative 2. Now I need to take care of some multiplication. I have 2 pieces of multiplication. You notice how I have a negative and a negative. That's our double negative. So I can go ahead and take care of him. That turns into a plus, doesn't it? So I have 2 plus 25 plus 3 times negative 2. And I have more multiplication, so let's go ahead and take care of 3 times negative 2. 2 plus 25 plus negative 6. Okay. 2 plus 25 is 27. And you'll see that 27 plus a negative is really going to be 27 minus 6, which is going to leave us with 21 again. A lot of 21s here. Okay. And I believe that is it for this lesson on evaluating expressions.